Alright, so we're continuing with chapter 4, and we're really just looking at a few definitions before we get into some of the theory. So before we talked about what a global maximin is, that's also uh, global also means absolute. And so we also looked at local maxes or mins, and that there's a synonym. Uh, we can also say that that is a relative max or min. Sorry about that. I was trying to say synonymous there and it wasn't coming out. Okay, so local max min, global max min. That's what that's the vocabulary I usually use. So then we talked about what it means to have uh, an extreme. So next, the next definition is something called an extreme point. And it's pretty straightforward. An extreme point is either a max or min. So think of an extreme point as a collective, right? If I don't want to distinguish between maxes and mins, I'll just say extreme point. So find extreme points means I have to find both maxes and mins, for example. Okay, so extreme points are both maxes and mins, both or either, depending on what the question is like. Okay, what is a critical point for a function? A critical point for a function is a point x where either one of two things happens. Either f prime of x is equal to 0 or f prime of x does not exist. Okay, and so let's take a look at a graph and see where those two cases might be, right? So in general, right, if I have a function over a closed interval from a to b, right, and I think of my function as like a little string there, right? So I'm thinking of f as being a continuous function. Then the function, you can just see, right, that the function must have a global max and a global min, right? And the interval, the interval here must be closed for this to work because that's where I'm putting, or I can think of this as kind of nailing down my function between these 2 points, and then the function is like a string between those two that's kind of just sitting there. And so what I'm looking for is the absolute smallest value, that the smallest y value, and the absolute biggest y value. Okay, and so if the function is continuous over a closed interval, then the function must have a global max and a global min. Okay, and that is called the extreme value theorem. Now remember that we had the IVT before. That was the intermediate value theorem. Now we're looking at the extreme value theorem. And the extreme value theorem says that let f be continuous on a closed interval from a to b. Closed meaning it contains both of its endpoints here. Then f attains a global max and min on the interval. Well, that's nice. But this is very much like the intermediate value theorem, right? Where the intermediate value theorem said that a point exists, where the function crosses through all the different y values, but it didn't tell you how to find it. The same thing happens here. The extreme value theorem tells us that the global max and min exists, but the extreme value theorem does not tell you how to find it. Okay, so we're going to develop a technique for finding that in just a second. But first we're going to take a look at Fermat's theorem. Okay, so Fermat's theorem says that if you have a function that has a local max or min at x equals c, and if f prime of c exists, then f prime of c is equal to 0. Okay, so in this graph here, right, you could draw a picture to see kind of how that works. So in this first case over here, if the function is differentiable and it's a max, right, that must mean that the derivative is 0. But it could be that the function is not differentiable, in which case you might have like a pointy edge here. And so there's a case where we have a local max, but the derivative is not equal to 0. The derivative does not exist. Okay, but if the function is differentiable at the local max or min, then we can be assured that the derivative is 0. Okay, so putting both of these two cases together, right, we can come up with a little bit of a theorem here, and that says that if f has a local max or min at x equals c, then x equals c is a critical point for f. And this is where we really want to start today is talking about how to find these maxima and minima. Blah blah blah. Okay, maybe I need a little more coffee. Okay, I don't know if I need more coffee. Okay, so we're going to find the local maxima and minima in just a second, but I think it's probably easier to start off a little bit behind, go back a little bit and talk about how do we find a global maximum. So let's go back to the extreme value theorem. Okay, and so we'll assume f is continuous on the closed interval from a to b. And then think about all the different cases that you might run into of how the function might be sitting. So here's an example. I might have a function like this, right? And so let's go through this function here and identify where the local maxima are and where the global maxima are. So in the picture, you can see that we have a local maximum here. We have a local maximum or local minimum here, local maximum here, and then is this point right here, like at point A, were we able to call that a local minimum? No, because this is an endpoint, right? So we can't call that a local min. And similarly here, can we call that a local min? No, because it's an endpoint. However, can this be a global min? It can. And actually in the graph you can see that it is the global min. And by the way, this is be the global max. Oops. I think I just hit something weird, so let me rephrase that. So here at B we see that we have a global min. Even though it's not a local min, right, it can be a global min, and over here we have a global max. And so the other points, this would be a local max and local min. Okay, good. So let's see where we can see how we can find these values, and then we'll go through an example. Alright, so this is the closed interval method for finding global extrema. Number one, compute all critical points. So CPs means critical points. Remember, that is where f prime of x equals 0 or does not exist. Some people forget the does not exist part. That's an important piece. These are candidates for where the global max or minimum may occur, but it may not be, right? So the second thing is we build a table where we have our x and our y, and in the x column we put the critical points and the endpoints. And then we just on this side, on the right side, we just look for the largest and smallest values. And that's it. That's how you find the local or the global max and min. Okay, so let me pause it again here. I'm just giving you a warning in case stuff starts popping up on your screen without any warning. So I'm going to draw or come up with a function, and we'll try the closed interval method for finding the global extrema. Alright, so we're going to find the extrema for the function x cubed plus x squared minus x on the interval from -1 to 1. Okay, and we're going to use the closed interval method. So the first step is to find critical points, and so we set f prime of x equal to 0. We notice we have a polynomial here, so there won't be any points where the derivative does not exist, and so our derivative is 3x squared plus 2x minus 1. Okay, And so we're going to set that equal to 0 and solve. Let's see, does that thing factor? Maybe we'll get lucky. That would be a 3x and an x, right? Oops. And so it looks like -1 plus 1. Does that work? That gives me my -1. Do I get a 3? Yep, I think that'll work. So therefore, x is equal to -1, or x equals 1/3. Good. Now the second point was to build our table of x and y, and on the right, or on the left side here, we put our endpoints and critical points. I usually go in order. We have -1. Notice that that is a critical point already. So that'll make our computations a little bit easier. -1, and then 1/3 is the next one, and +1 is the point after that. That's the other endpoint. And so if I plug in my f of x values, right, if I plug in -1, I get -1 plus 1 minus 1. Is it going to be a +1? I think so. And then if I plug in 1/3, let's see, I'm going to get 1/3 would be 1/27. I think it becomes -5/27. You can double check that. And then if I plug in x equals 1, you can see it's 1 plus 1 minus 1 would be 1 again. And so therefore, it looks like the global max is 1, and it occurs when x equals -1 or x equals 1. You could say and there if you wanted to. The other extrema is at -5/27, and that is the global min is -5/27. It is a y value, right? It occurs when x equals 1/3. Good. And before we leave this one, we're kind of running out of time. I just wanted to show you, if you go to Wolfram Alpha, sometimes it's nice to plot these things. So here you see our function being plotted from -1 to 1, and so we can take a nice visualization. And you can see here that at this endpoint, at this -1, we have both a critical point and an endpoint, right? And that's also the global max. And similarly over here, we have a global max but not a critical point, right? And down here we have both a critical point and a global minimum. Okay, so those are some combinations of where maxes and mins can occur. Sometimes it's nice to plot these functions just to visualize what you're thinking about as you go through. But that is the closed interval method. Good.